the screencast will explain this definition of a limit being infinity. And that's true, that's just shorthand for if and only if for all positive m, there exists a delta such that as long as you're within delta of a, and of course a has to be in the domain of g, that means that g of x is at least m. And this is very similar to the definition of a limit. That says instead of for all m, you have for all epsilon. There exists a delta the same such that x is within delta of c is the same. F of x minus L is less than epsilon. That's a little different from here, but we'll see that they kind of mean the same thing. So for this, right, if you just try and draw a function and you pick any point C here, this is a nice continuous function. Here's L. What this basically says is that if you pick any epsilon, like so, there is a delta interval such that as long as you're you never kind of hit. So as long as you're within delta of there, you're going to be good. And I can just go out delta the other way too. Actually, that's not true. Yeah, there. C plus delta. As long as you're within these two numbers, you're going to be within this kind of epsilon cylinder. So basically, you think of this as, right, someone's giving you a challenge. You're saying the limit's L, and the guy says, oh yeah, well, can you get within epsilon between these two red lines of L? I suppose these cylinders should be really red. Okay. Yep. So the challenge is, can you make sure that the function is within this red rectangle right here? And your response is, yeah, there's a delta, and then you'll always be that way. Well, this is the exact same game. So here's kind of a standard function that's going to go up to infinity. Drawn an asymptote, as we normally do. That's the point C. And then boom. That's not really a function right there, so just ignore that part. Right. So, same idea. They're giving you an epsilon challenge. Here, you're saying that that g is going up to infinity. Well, what does it mean if it doesn't go up to infinity? That means it always stays below a certain number, which we'll call m. So he's giving you an epsilon challenge over here. Over here they're saying, okay, I don't really think that it's going off to infinity, so I'm going to give you a challenge. Here's an m. Right? Can you give me a delta such that as long as you're close enough to C, you're always above that m? Well, in this case, yeah, as long as you're kind of within this interval, like so, this should be your delta. Right, because this is kind of the narrower of the two options. So here you have C minus delta, right there. And as long as you're within kind of these parameters, you're always going to be above m. Now, of course, this person that you're talking to is tricky. They'll change the game on you. They'll say, okay, let's get even closer. So they can give you a different epsilon interval over here. And then, of course, what you're going to do is you're going to respond with a different delta interval, right? You can say, okay, delta needs to be smaller in order for that to happen. I'm just drawing it in there without being all that careful. So the same thing can happen over here. They can say, okay, fine, you proved to me that you can always get bigger than that m, but how about this m, right? It has to be for all m. Well, again, if you notice over here, if you go straight down here, as long as you kind of get closer, so here's kind of a new delta. Here's a purple delta. So this is the exact same thing, except now you're not trying to get close to number L. You're trying to get big. You're trying to always get bigger. So I encourage you to try this out with an example. G of x equals 1 over x squared. If you let epsilon be bigger than or let m be bigger than 0, and then at c equals 0, then you can choose delta is just equal to, say, 1 over square root of m. Because then what you get is you get g of x, right? If x minus c 0 is less than delta, you get g of x is bigger than or equal to, I can replace that with something smaller, 1 over square root of m squared, which gives me m. So g of x is bigger than or equal to m, and we're done.